Welcome back, welcome back, welcome back. I'm Miss Lisa. This is my YouTube channel about all things science and math. And this is physics class, and we are going to be talking about gravity. So look, there's some astronauts. In fact, this is Universal Gravitation, and this is going to be the math for the part 1 video. This is part 2, so go back and listen to part 1 if you haven't. There's the picture of the equal areas that the planets map out in equal times. So they go faster here and slower there that I told you about. This is the lab that you're going to do where you do the push pins and make the oval. Okay, so here's our first problem. Okay, so you read it silently while I read it aloud. Okay, it says, Galileo discovered 4 moons of Jupiter. Io, which he measured to be 4.2 units from the center of Jupiter, has a period, remember that's the time per revolution or whatever, of 1.8 days. He measured the radius of Ganymede's orbit at 10.7 units. Use Kepler's third law to find the period of Ganymede. Okay, so how do you do physics problems? You list your knowns and unknowns, find a formula, and do it. So this is how I did it. So the first thing he told us was the radius of Io was 4.2 units. The second thing the book told us was the period was 1.8 days. Symbol for period is a big T. Then they told us the radius of Ganymede was 10.7 units, and we need the other period, okay? And here's the formula, Kepler's formula, is that there's a ratio between the period squared and the radii cubed. Okay, so when you have a formula, you write it down, then you sing substitute and put the numbers in. So the my period that I was given was 1.8. The other period is what I don't know. The period of that 1.8 goes with the radius of 4.2, so I put 4.2 on the bottom. And the radius I have that I don't know the period of, I put on top. I put the things I don't know on top and the things I didn't know bottom. You can actually switch these as long as you put the ones you know like on the same one. These could have been A's and those could have been B's. So I've got it all filled in. These are squared and these are cubed. So the next thing I'm going to do is I'm going to just do that part of it on my calculator. So let me show you how to do that. Get out your trusty TI-84. Turn it on with that button right there. Okay, this is my regular math screen. I'm going to clear it out because it looks very messy. Clear out what's in there. Okay, and now I want to do this. Okay, so I'm going to do beginning parentheses, 10.7 divided by, that's my fraction bar here, 4.2 in parentheses, and I need to cube it. I need to take it to the third power. Where do I get that? It's this button right here that says math. I always think that's the ironic button because aren't they all math? If you go down to number 3, it's cube things. You can either push 3 or arrow down. I used the arrows and went down and hit enter. And there it is. So I can hit enter. And I get that it is 16.5349, etc. So that's what this equals. But I want to find out this. So what's making this hard? Don't ignore the square root thing right now. What's making this confusing is that this is squared and that's squared. So I want to get rid of this squared and free this up. And the opposite of squared is square root. And I can do that as long as what I do to one side, I do to the other. So I take the square root of both sides. So I'm going to take the square root of this. So I'm going to do second x squared. See the little square root sign? And I'm going to type this in. 16 point. Now there's a way you wouldn't have to do this where you could like put it all in the beginning and stuff. But that would be more confusing. I'm about to drop my thing here. Hold on. Okay, sorry about that. Look at that. I got an application here where you want to quit that. All right, that's pretty good. We'll go with that. All right, so there's this. I'm going to square root that, and I get this number, 4.066. So that freed it from its radical, and now I can just solve for this by doing the opposite. It's being divided by 1.8, so I'll multiply both sides by 1.8. These cancel out because I have one in the numerator and one in the denominator. So I do 4.0 0.066 times, and you can just hit times, it'll bring down your answer, 1.8. And it says the answer is 7.31, and your book says about 7.3 days. So yay, we got the answer. And know that sometimes my work looks different than the book, and that's okay. If you like the book better, it won't hurt my feelings if you do their math instead. All right, let's do number 2. Using Kepler's third law, find an orbital radius. Okay, the fourth moon of Jupiter, Callisto, has a period of 16.7 days. So the period of Callisto equals 16.7. Remember, what we do is physics problems are word problems, and we want to get rid of the words. So what we do is, as we read it, we start writing down the numbers. Find the distance from Jupiter. So the next thing I put was distance equals question mark, but I'm telling myself that's going to be a radius. I know it is. Find the distance from Jupiter using the same units Galileo used. Okay, well, Galileo said that the period of Io was 1.8 days, and that the radius was 4.2 units. So now I can set up my equation. The period of A to B squared is to the radius of A to B cubed. So my things I know are the Io ones, and I'm going to put them on the bottom, 1.8 and 4.2. I was given the period of this one, so I write it for period, and the radius is what I don't know. So what I'm going to do first is this. I'm going to divide it and square it, and I get it's that. Now this is cubed, so I need to take the cubed root of both sides. It's just like a square root, but it's a cubed root, so that I can free this out away and make that cubed thing go away and break them apart so I can solve for it. So let me show you where that is on your calculator. So I'm going to go to the math button, and number 4 is the cubed root. So I'm going to go down to number 4 and put it there, put it on. And now I'm going to put this number in, because I'm going to take the cubed root of both sides. So I'll put in 86.077. Enter. And I get that it is 4.41. Now this is out, and I can just multiply both sides by 4.2. So I'm going to do times 4.2. And there's the right answer. So if you need me to show you that, let me get me a pencil out. Okay, so once it's here, then it was, I'll write right there. Okay, so we had that, when we took the cube root of both sides, we had 4.41 equals, excuse me, the radius over 4.2. Why is radius not alone? It's being divided by 4.2. So I do the opposite, which is I multiply 4.2. And we're allowed to do anything we want in math as long as we do it to both sides. So we multiply those and get that. All right, good job. Let's see if we have any more math here that we need to do. Yes. All right, problem number 3 on page 165. Okay. A satellite, so there's a satellite one. A satellite in low Earth orbit is 225 kilometers above the surface. So I said the height above the surface is 225 kilometers. What is its orbital velocity? Velocity equals, I don't know. Now, I'm going to need to use some of these equations up here. You always know that you're going to be using some of those equations. And so I need to see what's in these equations, and it's got the universal gravity constant, big G's, and it's got the mass of the Earth. So I should probably write that down too. Oh, and it's got R, the radius of the Earth. So these are all constants that you look up, or they're given to you, or you memorize them. So this is the radius of the Earth, 6.37 times 10 to the 6 meters. The mass of the Earth, 5.98 times 10 to the 24th kilograms. The universal gravitational constant is 6.67 times 10 to the negative 11th Newton times meters divided by kilograms, meters squared divided by kilograms cubed. So it's a fancy little number there. And then so I need the radius, and it's going to be the radius of the Earth plus this height. So we got the radius of the Earth plus this extra height here, okay? But this, always watch out for these little trip-ups they give for you. The height was in kilometers, but the radius of the Earth was in meters. So the first thing I need to do is change these kilometers to meters, and you do that by multiplying by 1,000. You can remember it by, let's see if I've got a little room here. King Henry's daughter bakes delicious chocolate muffins. So I'm at kilometers, and I need to go to the basic unit of meters. So I'm going to move my decimal point 1, 2, 3 places in this direction. So I go 1, 2, 3, augmenting zeros, and there's the answer. 225,000 meters, okay? So now I've got all my little things here, and now that these are in the same units, I can add them together. The radius of the Earth plus that. Now let me show you, just in case you don't know how to put that number in your calculator. That is a number in scientific notation. Let me clear out what's in here so that it's not so messy. Okay, so I'm going to put this number, the radius of the Earth, it's 6.37 times 10 to the 6th power. You put in the 6.37 first, 6.37. And then see this button right here? It's the second of the comma says EE. That button means times 10. So you do second comma, and it puts an E up there, which means times 10. And now we put this exponent in, we put in 6. We don't go up 6, we just put 6 in on this regular line, and this is how your calculator knows that this is that number. Do not do times 10 up arrow 6, because your calculator will see that as 2 separate numbers and you'll get the wrong answer. You might not get the wrong answer every time, but I think you'd get the wrong answer this time. So you want to put scientific notation numbers in using that button, that little EE. Okay, so we've got that one. Now we are going to say plus 225,000. And it tells me my answer is that 659,5000. That's my radius. And the book says, rounded it off to 6.6 times 10 to the 6. Okay, so here is my velocity equation. That's what I'm trying to solve for. Many times I've run off doing a great problem, just not the one they ask for. So make sure you're solving for what you're supposed to. And it's the gravitational constant times the mass of the Earth divided by the radius that we just solved for. So, and it's the square root of the whole thing. So let's put it in our calculator. Second squared is our square root symbol. Now I'm going to use the feature on my calculator for fractions that I like for numerator and denominator. If you don't have this, put the numerator in parentheses. Use the parentheses. Make sure you can get the right answer. But I'm going to do alpha y equals, and the first choice of the pop-up menu is numerator denominator, which means it's a fraction. And now I can put it in 6.67 EE times 10 to the negative 11th. And now I can say times 5.98 EE, which is my times 10 to the 24th. Now I arrow down to get in the denominator, and it's 6595000. And I just hit enter, and there's the answer. 777.689 meters per second. And if you want it in kilometers per second, you go back up here and you move your decimal point 3 places that way. 1, 2, 3. So it's 7.78 kilometers per second. Okay, that was pretty fun, wasn't it? All right, let me move this over here. See if we have any more math in this chapter. Look, there's our person in the space shuttle. There's the rubber mat illustrating Einstein's view of gravity. I don't quite understand it, I'll be honest. All right, Einstein just blows my mind. I think about it, but sometimes just can't wrap my head around it. All right, so that's it for this chapter. Science is great. Math is great. Like, share, subscribe. I'm Miss Lisa. Come back and we'll learn more physics. See you later.